Alright. What we're going to do in this lesson is talk about properties of atoms, and we're going to try to correlate trends in properties of atoms with their location in the periodic table and with their electron configuration. Alright. First, let's talk about ionization energy. The term first ionization energy refers to the energy that you need to remove one electron from a neutral atom. Okay, that's the minimum energy. Actually, that's the minimum energy that you need to remove an electron from a neutral atom. The second ionization energy is the energy that you need to remove a second electron after you've taken out the first electron. So that would be the third ionization energy. That would be the minimum energy you need to remove a third electron after you've taken out two electrons. Okay, so let's just do a quick check of that concept. What would you call the energy needed for this process? You have a sodium atom in the gas phase, okay, gives you sodium ions and electrons. Okay, see, this is an atom losing an electron, so the energy needed for this is the first ionization energy. And if you look at the second one right here, you have sodium with a +1 charge, losing an electron, okay, and giving you sodium with a +2 charge. The energy needed for this to happen is called the second ionization energy. So that's what ionization energy is. All right. Now, unless otherwise specified, when we use the term ionization energy, we generally refer to the first ionization energy. And like I said, that's the minimum energy needed to remove an electron. Now, the energy you need to remove an electron depends on the orbital where the electron that's being occupied by the electron. Okay, so valence electrons are easier to remove than core electrons. So you can think of the first ionization energy then as the energy needed to remove the valence electron from an atom. So here's an example. Sodium is 1s2, 2s2, 2p6, 3s1. That's the electron configuration. That's 11 electrons. So you have 2 electrons in the core, in the 1s orbitals. You have 2 electrons in the 2s orbital. Okay, 2s and 2p. So in the second shell, you're going to have 8 electrons. Okay, you have 2 electrons in the innermost shell, the 1s shell, and then you have that final electron, the outermost electron, much further away. Okay, remember, as you go to higher quantum numbers, you're going to higher shells, you're looking at the average location that's much farther away from the nucleus. So that 1 electron in the 3s orbital would be much farther away from the nucleus. So which electron would be the easiest to remove? That would be the electron in the 3s orbital. Okay? Let's do a quick check. Ionization energy of bromine atoms is the energy associated with which of the following? What did we say ionization energy was? Unless otherwise specified, we mean the first ionization energy. So we're talking about an atom in the gas phase losing an electron. So giving up an electron, what's left behind? That would have to be Br with a +1 charge. So that's this one right here. Bromine going to Br plus electron. Okay, that's